just so proud of what I saw this morning in all of the 4 schools that I was visiting. All the children, heads down. I could feel the excitement. I could feel the knowledge. I could feel the success that was going on. So my predictions for tomorrow: negative numbers, interpreting and using pie charts, and Roman numerals. Okay, Roman numerals, pie charts, interpreting charts and graphs, negative numbers, as well as the other topics that we're going to cover, like symmetry, we're going to do. That's what my prediction is for tomorrow. It might come up, it might not come up, but that's what was not in the paper today. So if we're going to try and get a nice, fair spread of topics, then these are the ones that I did not see. But in addition to those ones, you're going to get ones that maybe came up today, but in a different way. Wow. So let's get on with today's show. Now, I had a message earlier from a couple of parents for the GCSE, Maths GCSE. Now, Maths GCSE is the exam that the year 11s are going to take before they move on to tertiary, university or college or whatever. And they've got 3 papers. And paper 1 is tomorrow. So paper 1, GCSE Maths, is tomorrow. Higher tier and foundation, it is tomorrow. So we're wishing all of the GCSE students best of luck. And next week's show and the week after and the week after is going to be aimed at GCSE students, pupils, and also the year 4s who are going to be doing their MTC, that's their multiplication tables check, in June. That's the first week of June, between the 3rd and the 13th of June. And don't forget, there's a half term in between. So GCSE students, as you know, 2025, you are going to get a formula sheet, because what happened with COVID and lack of going to school, the government have decided they're going to continue with the formula sheet, and there's going to be a different one for foundation to the one that is for the higher tier. So you will get some additional support to direct you and to support you and to help you. So with the higher tier, your formula sheet shows you the quadratic formula, the solution. It shows you about perimeter and area and volume. It explains to you about Pythagoras, trigonometry, compound interest, probability, and the likes. So it's quite an exciting time. It's the exam season in all of our schools, primary and secondary. And I know that tomorrow, the GCSE students and the year 6s, you are going to be absolutely amazing. You are going to be outstanding. You're going to be phenomenal. And I just can't wait to go into a secondary school tomorrow to see how the year 11s are doing, and then to visit some more primary schools just to observe. Obviously, I can't say anything. I'm not allowed to walk around, but I can. But my presence, especially in the schools where I've been working and who know me, that is often enough to encourage our students. And of course, they need encouragement. But of course, the teachers have prepared them. And it's down to you, teachers, that our students and our pupils at the moment in all of our schools are doing absolutely so well. So big thank you to the teachers. Thank you to the parents, and thank you to the governing body of schools who are putting on breakfast for the year 6s, just to give them that energy boost, to feed that brain, and just to make sure that everyone is starting from a good position. So on with today's show. So today's show, we're going to be covering a range of topics. Now, remember, this is about revision. It's about revisiting. It is not just about teaching something new from scratch, because it's a bit late to do that. But what I am doing is I'm just going to be going over the topics that you already know. And then what you can be doing is finding out, if you know enough, if there are any gaps, and how you can move forward. So I've just had a message from a head teacher who has just said, go on. What he did say, he said, come on GCSE students, and come on year 6s, you rock. And that's from a head teacher. And I think that's absolutely perfect, because why can't a head teacher be down with the lingo and say that you rock? Because you do rock, and that means you're doing really, really well. So thank you to the head teacher. for your support. Parents, you can call in, send me a message if you want to support and encourage the GCSE students in year 11 and the year 6s in primary school, because you're moving on. So next year you're going to be in year 7, and what we say is you're going to be the small fish in the big pond, because at the moment you're the big fish in the primary school, yeah? But it's all going to change in September. But yeah, it's a brilliant time on with today's show. So we're looking at Key Stage 2. We're looking at the math SATs. SAT stands for Standard Assessment Test, and there is a requirement that schools have to report back to the government for Key Stage 2 SATs and the year 4 MTC, which stands for Multiplication Tables Check. So there's always a big push. There's always a big focus on preparing and supporting the year 4s and the year 6s, and of course secondary schools. You also have to report back on the GCSE pupils as well. Let's start with symmetry. Now, symmetry is about, well, symmetry and symmetrical. If something is symmetrical, it means it looks the same on both sides. If you take a beautiful butterfly, they look the same on both sides. Their wings and the patterns and designs are the same on both sides. Our bodies are symmetrical. If you put a line down the middle of my body, I have got one eye on one side, one eye on the other side, one ear on one side, one ear on the other side, one arm on one side, one arm on the other side, and so on. So reflective symmetry means it's got to look the same on both sides. So if they ask you to reflect a shape in a particular quadrant, then you must make sure it's the same size, the same number of squares, the same length, and so on. So it's like looking in the mirror, okay? So that is what we call reflective symmetry. The shape must look the same on both sides. And they give you a mirror, they give you a mirror line, so you are able to reflect that shape correctly, accurately. Translation of shape is my favorite part of symmetry, because with translation of shape, there's only 2 ways it can move. The shape can only move up or down, left or right. The shape does not rotate, it does not reflect, it does not get smaller, it does not get bigger. It stays exactly the same size. So shape translation means the shape can move to the left or to the right, up or down. And that makes it a lot easier to manipulate and to play with. So if translation of shape does come up, do not change the size of the shape, do not change the direction of the shape. You are merely moving the shape to the left or to the right, up or down. And they will give you the code. They will give you how they want you to move the shape. So do they want you to move it up or down 2 or 3 squares, to the left or the right 3 or 4 squares, and so on. So that is shape rotation, shape translation. We've looked at reflective symmetry. Rotational, they might ask you to rotate a shape 90 degrees anti-clockwise or clockwise 180 degrees, or indeed 270 degrees. So just remember the direction that they ask you to use. Clockwise is the way that our clocks, where the hands move. So they go to the right and they come back up to the left. Anti-clockwise is they start going to the left and they work backwards. So remember clockwise and anti-clockwise. Brilliant. So that's symmetry. It looks the same on both sides. Money came up today in a question. What you need to remember, year 6s, yeah, and everyone in general, we use 12 different amounts of money in our country at the moment. We use 12 different amounts of money in our country at the moment, okay? Right. The money that we use is this, because some children still, I hear them, they still believe or they think that we've got 3p coin, we've got a 4p coin, we've got an 11p coin. No, we haven't. What we have got is the following: 1p, 2p, 5p, 10p, 20p, 50p, £1 coin, £2 coin, £5 note, £10 note, £20 note, and a £50 note. So we use 12 different amounts of money. Now, if you add up all of that money that I've just read out, it will come to an amazing, brilliant number, and that is £88.88. So if you add up one of each of the money that I have just read out, the total would be £88.88. So £50 plus 20 is 70, 70 plus 10 is 80, 80 plus 5 is 85, 85 plus 2 is 87, 87 plus 1 is 88. Now, because we've got money symmetry, the same number that we use for pounds, we also use for pence. So if we've got 88 in pounds, we're also going to have 88 in pence. So remember the money that we use. Remember that our smallest money is the 5p coin. So think about the smallest money that we use. It's silver and it's round. Think about the shape of the 20p coin and the 50p coin. And think about going shopping, because sometimes they give you a purse and they say that so-and-so has spent some money on some fruit. They had £5. What is the change? You need to be able to understand money and manipulate money. So 12 different amounts of money, £88.88 from 1p to £50. Just remember money. Bar charts. So graphs and charts came up today. But I think that I've mentioned it earlier, I think that you might get a pie chart tomorrow. That's what I'm thinking. I might be right, I might be wrong. But my prediction, as I said earlier, is about interpreting charts and graphs, and it's about the pie chart. Why is it the pie chart? Because the pie chart is easy to read. It is circular, it is round. It's divided into sectors. And last week we spoke about the most popular sectors: halves, quarters, thirds, fifths, and eighths. And these are the sectors, these are the pieces in the pie chart that are the common ones. So you must know what they look like. So pie charts, they give us information, but it's easy to read because it's visual, it's interactive, and it is exciting. So remember, the word is sectors. That's the different bits that the pie chart will be divided up into. And the most common sectors that we use are half, quarter, eighth, third, and fifths, and maybe twelfths. So just remember, half of a half is a quarter, half of a quarter is an eighth, half of a tenth is a fifth, half of a sixth is a third. So, half of a third is a sixth, and half of a sixth is a twelfth. Half of a half is a quarter, and half of a quarter is an eighth. So just remember all of those sectors. Brilliant. Bar charts. Now, they used to give a lot of bar charts where the bars were going across horizontally, and the common ones is where the bars are going, they're going vertically from the bottom up. Horizontally is across from the left to the right. Now, they haven't done the vertical or the horizontal bar chart for some time. So if you do get a horizontal bar chart, think about the scale. Where is the scale starting from? How far across does that bar chart go? So you need to be able to read the name or what the bar chart is, what the bar is showing you, and how far does it go along the scale. If it's a vertical bar chart, then the scale will be on the left-hand side. Is it going up in tens, in 50s, in twos, in ones? Just remember how to read and interpret the bar chart. Remember, the y-axis is the vertical and the horizontal axis is the x. The y-axis is the vertical line and the x-axis is the horizontal line. So x and y, and remember in maths, in algebra, the letter x is not written like the capital letter X. It's two C's back to back. And the letter Y is not a capital letter Y, it's the lowercase letter y. Wow, there's so much information and so much knowledge that you get on the Math Show every Wednesday with me, Mr Numbervator, on Chalk Hill Community Radio Station, supported and sponsored by Sovereign Comics. And Sovereign Comics make the Mr Numbervator comics as well as other comics. And Sovereign Comics is Sovereign Comics, all one word, .co.uk. If you go to that website, you can get all the comics. You can find out all the information about the up-and-coming Comic-Con, because we're going to be at the Comic-Con. and that's the 24th, 25th of this month. So
26.
And 26th, yeah, 24, 25, and 26. That's Dean in the background. He doesn't want to show his face, but you heard his voice last week. Yeah, 24, 25, 26. So we're going to be there with the comics, selling not just the Mr Numbervator comic, but it's comics that Sovereign Comics make. It's all about edutainment, okay? Edutainment. It's about educating, but through that fun, interactive, hands-on, purposeful, exciting way. So we've looked at symmetry, translation, up, down, left, right, reflective, what our faces look like in water, in the mirror, rotational, 90 degrees, anti-clockwise or clockwise. And then we've looked at money, we've looked at bar charts, and we've looked at my favorite, which are pie charts. Number sequences came up today where you had to follow a sequence and a pattern. But the one that I think could come up tomorrow is my favorite one to do with fractions. Because you can have a number sequence with fractions, or you can have a number sequence with time. And they don't often do this, and I haven't seen it for a long time. So that is one of my predictions as well. So let's just say we've got a number sequence, okay? And let's just say we've got the fraction 1/4 is at the beginning of the sequence, right? So we've got 1/4. We've got an empty box, and then the next fraction is 1/4. So you need to write what goes in the empty box between 1/4 and 1/4. So let's have a look at this. Okay, let's have a look at this. To get from 1 to 1/4, what do you have to add? You have to add 1 whole. So you've got 1/4 plus 1 whole is 1/4, and then you've got 1/4 plus 1 whole, and so on. So what you are doing, you are following a sequence, okay? You are following a sequence. What happens if you've got 1/4 and then the next box is empty, but you've worked out that you have to add 3/4? What is 1/4 plus 3/4? That is 1 whole. So that if you're looking at the sequence, it can be 1/4, then you've got the next one is 3/4. How do you get from 1/4 to 3/4? You add a half. So the pattern is you're adding a half each time. So we're going to start with 1/4. If you add a half, you get 3/4. If you add another half, you get 1/4, and so on. So what you're looking at, follow the sequence. Find the difference between the boxes and then follow the rule. Another one that I've seen is they might give you the number 42. They might give you an empty box. They might give you an empty box, and then they might give you the number 28. What do you have to do to get from 28 to 42? For example, 28 plus 7 is 35. 35 plus 7 is 42. So the next number would be 49, and so on. So it's the 7 times table, okay? But you're working backwards. So just remember, they could give you a sequence with a particular multiplication tables, so you need to be able to follow and do accordingly. So number sequences can come in a variety of ways, shapes and patterns and whatever, but just follow the rule, follow the pattern. But listen, year 6s and GCSE, you're meant to enjoy your tests and exams. I know it sounds really weird, but you're showing off how much you know. And because you know a lot, you should feel really, really proud, really proud about what you can do, the knowledge that you've got, the information that the teachers have imparted to you, and so on and so on. Fractions, everyone knows, Mr. Numbervator's favorite topic is fractions. Indeed, when we started doing the comics with Sovereign Comics, the first comic was equivalent fractions by coincidence, but it's not by coincidence. is because fractions is my number one favorite topic in maths. Whether you're in primary, secondary, A level, degree level, fractions is my favorite topic. Why? Because it's all around us. It's just so easy and it's so much fun. Now, I know a lot of young people are out there going, oh, how can Mr. Numbervator like fractions? It's because of the way it is taught, or the way that I teach it, the way that I present it, and the way I get you to engage with me. Fractions is fun. Okay, so yeah, it's all about fractions. So what do you need to know for tomorrow? You need to know the 4 rules. When we talk about the 4 rules in mathematics, we're talking about addition, subtraction, multiplication, and division. So you need to know how to add fractions, subtract fractions, multiply fractions, and divide fractions. You need to know about adding fractions with the same denominator and adding fractions with different denominators. You need to know about equivalent fractions, and that was the first comic that we did with Sovereign Comics. It was about equivalent fractions. What are equivalent fractions? Equivalent fractions are fractions that look the same, but they look different, but they have the same value. So for example, 3/4 and 9/12, they look different, but they mean exactly the same value. So equivalent fractions are fractions that look different, but they have the same value. I've given you an example. 2/5 is the same as 4/10. They are equivalent fractions. The fractions look different, but they've got the same worth, the same value. That's what equivalent fractions mean. So please make sure you understand about equivalent fractions. Please remember, we do not call them mixed numbers, okay? When I was younger, we used to call them we don't call them mixed fractions, we do call them mixed numbers. They used to be called mixed fractions, but now we use mixed numbers. So for example, 3.5 is an example of a mixed number. It is not a mixed fraction. So please do not write that in any explanation that they might ask you to give. It is not a mixed fraction. It is a mixed number. What is a mixed number? A mixed number is a fraction that's got a whole number like 3, and then it's got the fraction bit like 3/5. So 3 and 3/5, a bit of a tongue twister there. 3 and 3/5 is an example of a mixed number, not a mixed fraction. KCF, not KFC chicken, KCF in maths is to do with division of fractions, where you keep, change, and flip. You know what that means. That's to do with division of fractions. And then when you are multiplying fractions, you simply multiply the numerators together and the denominators together. You might need to simplify, make the fraction look smaller, make it look easier to read. But these are all skills that you've been taught. You've been taught by your amazing primary school teacher. And all primary school teachers, as well as secondary school maths teachers, we are the best. I know that for a fact. I have only seen brilliant secondary maths teachers and outstanding, brilliant primary class teachers who we have to teach maths as well. So, Miss Phillipson, Secretary of State for Education, I've invited you on to my show hundreds of times. I've sent you hundreds of emails, but I've not heard anything back. But I'm going to say it again, you are invited to come onto the maths show. We can have some young people in the studio, and you can see how amazing our pupils, your pupils, are. So please, you know how to get through to me. I've sent you loads of emails. I'll send you another email. The maths show, it would be amazing to have you on the maths show. Can you imagine the parents and the teachers and the young people who would love to know that you support them and you are here for them? 07535 644 850. We're going to go for a quick short ad break, but when we come back, we're going to be carrying on with paper 3, which is reasoning 2 of the Key Stage 2 Math Sats, because that is tomorrow. Don't go too far.
Are you a grandparent with a new baby or infant up to 2 years old? From dropping
take the next step towards success.
I wanted a college to help me achieve my goals.
A supportive environment and expert tutors make all the difference to my learning.
Whether you're passionate about hair and beauty,
Are eager to pursue a clinical career,
or are aiming for university, we have a course for you.
Thanks to CNWL, I landed my dream apprenticeship and I'm well on my way to a successful career.
Apply today at cnwl.ac.uk.
The College of North West London, where your future begins.
whether you need to read up on the highway code or want to book a driving test, whether you need to plan a journey or find where to park with a blue badge, DirectGov is the website to point you in the right direction. DirectGov, public services, all in one place.
Go to www.sovereigncomics.co.uk and get your latest issue of Mr Numbervator's Maths comic book series today. You are now tuned in to the Mr Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical. Welcome back to part 2 of the Math Show with me, Mr Numbervator, on Chalk Hill Community Radio Station. And you just heard the voice of Paul on that advert. And Paul says, let's get mathematical. And that is exactly what we do on the Math Show. We get mathematical. But the difference with the Math Show is this: you are getting high quality, first class teaching on the radio. You are not going to get this level, this quality of teaching anywhere else. This Math Show is better than private tuition. It is the best maths that you can get anywhere on the airwaves. So every Wednesday between 5:30 and 6:30, we are getting mathematical. So well done. Thank you, Paul, for that lovely advert that we all listen to every single week. And Paul is from Sovereign Comics, and he's the master behind the vocabulary and the words, and it's amazing. Right, so we're revising for Key Stage 2 SATs. Paper 3 is tomorrow, which is Reasoning 2. You've had your arithmetic this morning. You've had Reasoning 1 afterwards, after playtime at some stage. So now tomorrow is the last one. And it's going to be really sad because that's it. It's all over. It's all over. But we're going through different topics, and I'm just giving you an overview of what you need to know. We've looked at symmetry, translation, reflective, rotational. We've looked at money. We've looked at horizontal bar charts, vertical bar charts. I've told you to look at the axes, the scale, and the increments. That means how is the scale increasing? Is it increasing in 2s, 5s, or 10s? We've looked at number sequences. We've looked at fractions, adding fractions with the same denominator, different denominators, equivalent fractions, fractions that look different but got the same value. We've looked at the difference between mixed numbers. We don't say mixed fractions. We've looked at division of fractions where we teach you to keep, change, and flip. And then we've looked at multiplication of fractions where you multiply the numerator by the numerator and the denominator by the denominator, and then you might need to simplify. What about fractions of amounts? That comes up. That comes up. It didn't come up today as far as I remember. Fractions of amounts. You divide by the denominator, you multiply by the numerator. So let's just say, for example, the question is calculate, find 3/4 of 600. 600 is the whole amount. So if I was teaching that to you using a bar, a rectangular bar, if I was doing it using the bar, then the whole bar would represent 600. My denominator is 4, so that means I'll divide the bar into 4 equal pieces. 600 divided by 4 is 150. I'm going to take 3 of those 4 pieces, so 3 times 150 is 450. So 3/4 of 600 using bar modeling is 450. So you divide by the denominator and you multiply by the numerator. So that is fractions of whole amounts. Recognizing fractions, sometimes they give you shapes and they ask you to say which shape shows, another tongue twister, which shape shows 3/4 or 1/4 or 1/2, and so on and so on. There are 2 words that I've been working with teachers today so that when they can go back into the classroom and start to prepare year 5s with their maths: perpendicular and parallel. 2 important words that come up. Parallel lines never meet. And it's interesting, in the word parallel, you have got 2 L's next to each other. And those 2 L's will never meet. Parallel lines never meet. You've got 3-letter L's in the word parallel. P-A-R-A-L-L-E-L. Those 2 L's that are next to each other, they are parallel lines. And parallel lines never meet. The other word is perpendicular. Perpendicular, you've got a horizontal line, you've got a vertical straight line. Where those two perpendicular lines meet, so where the vertical meets the horizontal, a right angle will be formed. And a right angle is 90 degrees. So perpendicular and parallel lines, please remember the difference, year 6, just in case they ask you, that, you know, just in case it might be part of a question and you're not too sure. Parallel lines never meet. Think of the word parallel, and in the spelling, you've got 2 L's. Those 2 L's, those 2-letter L's, they will never meet because they are parallel lines. Oh my gosh, isn't maths amazing? Yes, it is. Right, shape, 2D shapes. 2D shape, now I'm going to say it again. When I was teaching full-time, when I was in reception class in year 1, there was a storybook called Flat Stanley. And Flat Stanley is a shape, and Flat Stanley can fit under doors. That's the way he escapes. It's a brilliant book, but it teaches children about shape. A 2D shape is a flat shape. It can fit underneath a door. If it can fit underneath a door, it's a 2D shape, as opposed to a 3D shape like a cube, and it can't fit under a door. Now, I don't want people to say to me, what happens if the door's got a big gap at the bottom? We're not looking at that. We're looking at a normal door in your house, in a school. A 2D shape can fit underneath. A 3D shape cannot fit underneath. That is it. I'm not going to enter into any discussions about what happens if. Right, 2D shapes are like quadrilaterals. So you've got triangles, you've got a quadrilateral, you've got shape, you've got square, you've got rectangle. These are all examples of 2D shapes. So triangles, rectangles, squares, circles, and all of that. But you've also got some shapes. I'm full of tongue twisters today, alliteration. You've also got some shapes that are important. A quadrilateral is a four-sided shape. Quadrilateral is the family name for squares, rectangles, four-sided shape. So a four-sided shape is a shape that's got four sides. With a square, you've got four equal sides. With a rectangle, you've got two sides of the same length, and the other two sides are the same length as well. So the lengths are the same, the widths are different. But it can be the other way around. But you've got a quadrilateral, you've got a pentagon, a five-sided shape. You've got a hexagon, a six-sided shape. You've got a heptagon, which is a seven-sided shape. You've got an octagon, which is an eight-sided shape. You've got a nonagon, which is a nine-sided shape. You've got a decagon, which is a 10-sided shape. And you've got a dodecagon, which is a 12-sided shape. So these are all examples of 2D shapes, flat 2D shapes, but you need to know the number of sides, okay? So I've just gone from triangle 3 right through to a dodecagon. That's another tongue twister. A dodecagon, which has got 12 sides. Brilliant. Is it mad? I'm laughing at my own jokes now. Never mind. Right, so square numbers. What is a square number? Well, a square number is literally from the word square, because a square number is where the result of multiplying two digits or numbers that are the same. So 2 times 2 is 4. So 4 is the square number, not the 2 times 2. 4 is the square number. That's really important. 36 is a square number because it's made from 6 times 6. 49 is a square number because it's made from 7 times 7. So 49 is the square number, not the 7. And I've seen that mistake being made. So please remember about square numbers, numbers that are the same multiplied together, like 2 times 2, 5 times 5, 12 times 12, 13 times 13, 20 times 20, 6 times 6, 3 times 3. These are all examples of square numbers. You've also got cube numbers, and that's where you multiply the same digit or number by itself 3 times. So for example, 10 times 10 times 10 is 1,000, because 10 times 10 is 100, and 100 times 10 is 1,000. So 1,000 is the cube number, not the 10. 1,000 is the cube number. If you've got 4 times 4 times 4, 4 times 4 is 16, 16 times 4 is 64. So 64 is the cube number, not the 4 times 4. Please remember, it's really important. Square numbers, cube numbers, factors. A factor of a number is a number that can divide into that number. So factors, let's say of 24, are numbers that can divide into 24. Factors of 24 are numbers that are smaller than 24 or equal to 24. That's really important. So factors of 24, I'm going to go in ascending order. Oh, there you go. Ascending order means we're going from small to big, and descending order means we're going from big to small. So I've just used some vocabulary very incidentally, which means without even thinking about it, but it's important that you know the difference between ascending and descending order. Every number in the world has got at least 2 factors, 1 and the number itself. So factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So each of those numbers can divide equally into 24 with no remainder. I'm going to say it again. 1, 2, 3, 4, 6, 8, 12, and 24. So factors of 24 are numbers that can divide into 24, smaller than 24 or equal to. So you cannot have a factor of 24 that is bigger than the number 24. It doesn't work like that, okay? So that is what is meant by factors of a number. Remember, I've just taught you about ascending and descending order. Multiples of a number are, a multiple of 7 is a number from the 7 times table. So 7, 14, 21, 28, 35, 42, 49, and so on. So multiples of a number are numbers that are divisible by that number. So 14 is divisible by 7. So 14 is a multiple of 7. Remember the difference. Going back to the vocabulary, I've mentioned ascending order and descending order. Remember, in mathematics, the word sum, spelled S-U-M, means addition, and the word product, P-R-O-D-U-C-T, means you are multiplying. So the sum of 3 and 4 is 7, because 3 plus 4 is 7. The product of 3 and 4 is 12. So please remember the difference between the two. Sum, S-U-M, not S-O-M-E. That's what we call homophones, words that sound the same but are spelled different. So sum is S-U-M, you add, and product is where you multiply. Remember to use the word digit and number correctly. Okay, so the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Numbers are 10 upwards. Okay, so remember the use of the vocabulary, digit and number, ascending and descending order. Percentages, yeah. Now, when you're calculating a percentage of an amount, remember to break it up. So if you've got the number 300, okay, for example, what I would do, I'd work out 1% of 300, which is 3. Then I'd work out 10%. Then if you know 10%, half of 10 is 5, you can work out 5%. Then you can work out 25%, which is a quarter. Then you can work out 50%. Then you've got 100%. So percentages, the word percent means per 100, out of 100, okay? So that's what the word percent means. So if you've got a square with 100 small squares in it and you color in 2, you've colored in 2% of 100. That is 2 out of 100. So that's what percentage means. So you might have to work out 20% of 600, for example. So you work out 10% of 600, which is 60, and then you double it to get 20%. So I always break it down into 1%, 5%, 10%, 25%, 50%, 100% is not everything. Another classic question is 99% of 100, or of a number. Now, if you know 100% is 100, 99 is 1 away from 100. So if you're working out 99% of 600, you have to just simply work out 1% of 600, which is 6, take it off the 600, and you got the answer of 594. You can do 99 over 100, so the denominator will always be 100, times by 600. You can do it that way, but that can be quite tedious and laborious. That means you're working unnecessarily too hard. So just remember about percentages, yeah? Listen, we have been through so much this evening, okay? We have been through so much work. It is unbelievable, yeah? And it's all about you, year 6. It's all about what you can do and what you know. So my prediction for reasoning 2, which is paper 3 tomorrow, negative numbers, that's numbers that are below 0. Pie charts, interpreting charts and graphs, you might get horizontal or vertical bar charts. Roman numerals, so I, V, X, and so on and so on. We did it last week. And then pie charts. So year 6 is left for me. It's not the end of the math show, by the way, but it's left to me to wish you the best of luck for tomorrow. I know you're going to go in there, and each year 6 pupil, you are going to nail it. How do I know? Because you have been taught by fantastic, amazing, outstanding teachers. You've got fantastic, amazing, outstanding parents. You've got the fantastic, outstanding Mr Numbervator. Everything is going your way, basically. And you have got fantastic, amazing, outstanding brains, year 6. So put them to the test. Read the question. Underline the important words. If there's a word in bold black letters, it means that word is important. So make sure you underline it and you understand the meaning of it. read the question, make it come alive, enjoy paper 3 tomorrow, which is reasoning paper 2. Have a great time. Once you've done it, I know that there's parties. I know that some schools are having pizza afternoons tomorrow to celebrate the end of the SATs. There's a lot going on. When I was full-time, we used to have a cocktail party, a fruit cocktail party, by the way, for the year sixes, where they had to dress up in their suits with the bow tie and jacket and trousers. And then we had a cocktail where we designed fruit cocktails. So every child had a fruit cocktail named after them. And then that's what was made for all the children, and parents were invited, and it was amazing. But it was just a lovely way to celebrate the end of the SATs and the end of year 6. So year 6 is well done. Have a great time tomorrow. And send me a message. Let me know how you get on. And the results will come out sometime in June, July, and then that's it. Whatever school you're going to, the SATs, the result does not affect the school you're going to, because you're going to that particular school. That's all you need to worry about. Let's turn our attention for the last part of the show to tomorrow again, because tomorrow is paper 1 for GCSE math students, okay? So it's paper 1 for GCSE math students, and a couple of parents asked me just to run through paper 1 and some topics, just to explain very, very briefly what you need to be able to do. I've got a GCSE maths paper in front of me. It is a higher tier paper. Once again, you do get your everyone will get their formula sheet. So the higher tier formula sheet is different to the foundation stage formula sheet. So I've looked at the formula sheet for the higher tier. It's quite straightforward. But let's look at a couple of questions before we finish. Some usual questions. Calculate, work out 4.62 divided by 0.12. So we don't say 0.12, we say 0.12. How would you do that? Well, what I would do to help me is that I would write the multiples of 12. So I've got 0.12. I have multiplied that by 100 to get 12. And then I'm going to write down the 12 times table, and I'm going to do 462 divided by 12. And then once I've got my answer, I can then adjust it accordingly. So that's what you can do there to help you. Okay, so there's usually some decimal numbers at the beginning, just to test that you understand about number. Fractions, we do fractions in, we've got some mixed numbers here, but we do mixed numbers in Key Stage 2. So one of the questions that I'm looking at here is 5 3/10 subtract 3 2/5. That's a classic, that's higher tier. That is a typical higher tier fraction question, but you need to be able to do it, okay? Another one is about the shape, the cube, and volume. A cube has a total volume of 64 centimeters cubed. Work out the surface of the cube. So, what do we know about 64 centimeters cubed? Well, we looked at cube numbers in Key Stage 2. That's 4 times 4 times 4. So the cube root of 64 is 4. That means that you've got your 6 squares. Each square, the sides are 4 centimeters each. 4 times 4 is 16. So you've got 6 lots of 16, which is 96. So yeah, so just remember about surface area. You've got frequency, you've got polygons. Remember what a polygon is? It's a shape, it's a straight side shape, okay? You've got Venn diagrams where you're being asked to, you've got the universal set, which is everything. Then you've got set A, which is even numbers, set B, which is square numbers, and you've got to put the numbers in the correct set. And then they might ask you, find the probability that the number that, a number is chosen at random from the universal set. A number is chosen at random from the universal set. Find the probability that this number is in set A. So because you've done your sorting using the Venn diagram, you can then do the maths. Scatter graphs, which is very interesting. I love scatter graphs, okay? And you need to think about the line of best fit. You need to think about where the numbers are starting from. And then you need to think about positive correlation. The word correlation means relationship, positive correlation, negative correlation, no correlation or zero correlation. And then what does that mean? So for example, positive correlation, if we're looking at the number of umbrellas sold according to the months of the year, as the months of the year starting from January, as you go from January through to December, the weather starts getting warm. So the sale of umbrellas is going to decrease as you go through the months of the year. So we're looking at, is that positive correlation, negative correlation? Positive correlation is where as you go through the months of the year, ice cream sales go up because the weather's getting warmer. So as you get to May, June, July, August, September, ice cream sales go up. So as one thing goes up, so does the other. So that's scatter graphs and correlations. Percentage increase, looking at cylinders, so pi r squared h and so on. Wow, there's a lot of simultaneous equations. Wow, that's another one of my favorites. A pentagon, I mentioned pentagon for Key Stage 2 just now. Here's a pentagon, so know about pentagons, tree diagrams, looking at the laws of indices, direct proportion, line equations. Oh, isn't this amazing? Here is a sphere, which is the shape. 5/8 of the surface area of this sphere is 375 pi centimeters squared. Make X the subject of the formula. Oh, this is a lovely paper. Oh my gosh. A tailor's shop sells jackets, shirts, and pairs of shoes. The shop sells 7 varieties of jackets. The shop sells X varieties of shirts, and the shop sells 3 varieties of pairs of shoes. And you have to work out certain numbers. You've got angles, you've got circle theorem. You've got, yeah, that is it. So listen, GCSE students, once again, I wish you all the very best. You've been taught by amazing, outstanding, brilliant teachers. You've also got amazing, outstanding, brilliant parents and carers and everyone in your household. You cannot go wrong. I know that this year, Miss Phillipson, Secretary of State for Education, Skills and whatever, this year, 2025, is going to be the best year for maths across the country. Why? Because in your schools, in our schools, we have got the best teachers. Please come on to the maths show, Miss Phillipson. You are more than welcome. You've got my number. I'll send you another email. I sent you about 12 emails, and I was hoping that as Secretary of State for Education, someone might at least send me a reply, but nothing. But this is the maths show. You're welcome to come on. I can get a group of young people to come into the studio. I can teach them in front of you. We can record this live. It would be such an amazing session, radio show. Parents can call in and ask you questions, and teachers. So you're more than welcome. Good luck to year 6. Good luck for GCSE paper 1 tomorrow. We will cover paper 2 and paper 3 of the GCSE. We'll look at year 4 for your multiplication tables check as we go through the coming weeks. Have a great week. Best of luck to everyone tomorrow. Have a great weekend. The weather's looking promising, and I'll see you all again next week, Wednesday, 5:30 to 6:30, Chalkhill Community Radio Station with me, Mr Numbervator. Goodbye.